The following is the video solution from JSDT Solutions. Question 6 says, in the diagram below, ABD is in the horizontal plane and BC is a vertical pole. The angle of elevation from A to the top of the pole is equal to x. And then we also told that it's given that angle ADB is equal to 2x and CBD equals 90 degrees and AD is equal to BD. Okay, and we need to prove that AD equals h over 2 sine x tan x. Okay, so the main goal is find an expression for the length of AD. So here's what we can do. To find AD, we're going to have to use this triangle first, since that is the triangle that AD is a part of. And we could just go ahead and use the sine rule. So to use the sine rule here, we need this side because this is what we're looking for. And then we need the angle opposite it. And then we need another complete side. Now this is an isosceles triangle, meaning these two angles would be exactly the same. So we could think about using this side and that angle and then this side and that angle. But the problem is these two are exactly the same. So BD is also AD. Okay. Now at this point, we can just look at what we have here. Notice how we have H. So H comes from this triangle. So somehow this is involved. We have to get that. So the only way to include H in this triangle is if we were using H so that we could find AB. So instead of in this triangle, using this side AD with the angle opposite it, and then using BD with the angle opposite it, we're not going to do that anymore. We're rather going to use AD with that angle and then this angle with BD. Okay, so using the sine rule. So the main goal is find exactly what this angle is over here and then find an expression for AB. Okay, so it's an isosceles triangle. Let's go ahead and start with these angles. So this is 2x, meaning the angles in the triangle add up to 180 degrees. And so this angle, let's just call it angle ABD. Angle ABD would be found by saying 180 degrees minus 2x, right? But then remember that these two are exactly the same. Okay, so you can't start by doing that. But the thing is, with 2 and 3D trig, it's not Euclid where you need to put reasons. Okay, so we can just tell them that angle ABD is equal to angle BAD. So angle BAD, those, because we have an isosceles triangle. And so let's go ahead and find angle ABD. So this is 180 degrees minus 2x, but then there are two of the exact same angle. So to find one of them, just divide that angle that we find by 2. So 180 degrees minus 2x divided by 2. And so this means that angle ABD is simply equal to 90 degrees minus x. Okay, so we found an expression for this. ABD is 90 degrees minus x. And now all we have to find is AB. Okay, and then we'll use the sine rule. So looking for AB. AB can be found using this right angle triangle here. We already have x, and we need to include h. So we're taking the opposite side and we're trying to find AB, which is the adjacent side. So opposite and adjacent means we need to use the function tan. So we'll say tan of the angle there, which is x. Tan x is equal to the opposite side is h over the adjacent side, which is AB. So h over AB. And we're just trying to find out what AB is. So to make AB the subject, you can just multiply both hand sides by AB. And so you'll be left with AB tan x here. And then divide both hand sides by tan x to get AB on its own. So what that would do, it will result in us having AB is equal to h over tan x. Okay, I'm just seeing it as transposing the AB and then it goes to the numerator, transposing the tan x and goes to the denominator. Okay, so this is what we have for AB. And now finally we can use the sine rule here. Since this is h over tan x, using the sine rule, we're simply just saying we're trying to find AD. So we'll say AD over sine of the angle opposite it. So the angle opposite AD is that 90 degrees minus x. So 90 degrees minus x is equal to, and then we're going to say another side that is available, which is AB over sine of the angle opposite it, which is the 2x. So sine 2x. But we already know that AB is h over tan x. So this is h over tan x. And now all we have to do is simplify. So this is AD over, we can use cofunctions here to simplify that. So sine 90 minus x is equal to cos x. And this is equal to, and this is a fraction, h over tan x. And we are dividing by sine 2x. So we can use tip and times here. So if you put this over 1 to make it a fraction, you're going to have to tip it, meaning swap the numerator and denominator, and then change the division to a multiplication. So now we just have AD over cos x is equal to, and these multipliers will become h over tan x sine 2x. Sine 2x can be expanded, so let's just expand it. So it's going to become 2 sine x cos x, okay, using double angles. And finally, to just get AB on its own, we can multiply both hand sides of this equation by this cos x in the denominator. So times cos x. And so finally, AD would be equal to, we have the cos x going to the numerator because it's multiplying to the numerator. It's cos x over 1. So that's h cos x over, and we have tan x times 2 sine x cos x. And cos x cancel on the numerator and denominator. Therefore, AD is finally equal to h over, and this will simplify to 2 sine x tan x, just like they have it. Okay, so that is our answer, and that is the only question we have for question 6.